Okay, so precision ag and manure, typically not, I'll say two topics you hear in the same sentence. Let me start off by saying I've been to a variety of meetings, both internal, external, OMAFRA, as well as conferences on precision ag, and you literally never hear manure as part of the conversation. It's, you know, the various inputs, be it fertilizer, herbicides, whatever you want, but manure, for whatever reason, isn't thought of as being as part of, or integral as part of that rapidly evolving industry. And I truly believe there's a real opportunity here for producers to capitalize on using precision ag in conjunction with their manure, and both for economic and environmental concerns. So here we go. So looking just kind of, at the current status in broad general terms, you know, what we're seeing, again, with liquid manure, most guys are putting on somewhere around 5,000 gallons per acre. There certainly are exceptions. Probably the most notable, too tall, sorry, thanks. Okay, thank you. Yeah, so certainly there are exceptions. I mean, probably the most notable I know of is, I know of a custom applicator in Indiana who regularly claims he puts on 22,000 gallons of liquid manure per acre. Now, put that in context, that equates to about 3/4 of an inch of moisture you're putting on per acre. So rather significant and whatnot. We never, talking to him, certainly never got into the nutrient impact and what he was doing to the soil and whatnot in terms of overloading, but it's out there happening. On the solid side, there again, 15 to 20, certainly the poultry guys are on the lower end of that, probably maybe 4 or 5, depending upon what their unique applications are. But these are, it's not to say these are bad practices, but again, is there an opportunity here to capitalize on the nutrient content of your manure and do a better job of placing it where it's needed to be? So in that respect, you know, what can be done here? So looking at some of the challenges and opportunities, the first two certainly are challenges, and that is variation in manure nutrients. Right now, the challenge we have with manure, both solid and liquid, is the variability, both in agitated pits and a pile in itself, and the testing. I've run into it myself where you take a manure sample, send it off a week, 2 weeks, sometimes 3 weeks later, you finally get that sample back. So in a timely fashion, it really isn't suiting the needs of the producers trying to get the manure out and be effective about it. And certainly the other point, calibration of equipment. You know, tankers a little bit easier in terms of knowing what you're putting on. Again, the targeting of that, say, arbitrary 5,000 gallons per acre, it's a little bit easier to attain. But with the solid there again, with the variability in densities, loading and whatnot, it makes it a little bit challenging. But certainly with the evolving industry we have here in Ontario with, I'll use JLOR for instance, they have built-in scales on their solid manure spreaders. So you really, every load, you know what you're putting on in terms of, you know, this load is 6 tons, the next one's 7.5. It paints a picture for you, so you have really valid information going out into the field as you're willing to spread. The third one, nutrient value assessment. That's more so of an opportunity. My coworker Chris Brown's going to talk to that in a little bit, but there's a variety of tools out there, I'll say, whereby you can look at your manure assessments, what nutrients you have, do a comparison against commercial fertilizers of those same nutrients, and be able to paint a very vivid picture of what that economic return per ton or per gallon is for those manure nutrients. So again, real opportunity here to move the ball forward. And precision ag, as it stands right now, where the focus is, primarily 4 key areas: soil maps, yield maps, GPS tracking, and variable rate applications of inputs. Like I said before, right now, all those are focused on the traditional inputs, if you will. The seed with the variable rate application, the fertilizer variable rate application, the herbicides, you know, doing the comparison of, you know, your soil map versus your yield map and doing the correlation to say, I've got good yield over here, not so much here. What do I need to do in terms of managing my nutrients to improve the yield overall across those operations? Excuse me. And then getting into what can be done in terms of addressing this as it relates to precision ag and manure, bringing the two together and really moving the ball. So in terms of that, manure sampling and tools that will allow variable rate application of manure. What we're seeing is, and unfortunately not in Ontario, on manure sampling, we're seeing online live systems that liquid manure measure in real time, multiple times a second. So instantaneously, when you're sitting in the cab of the tractor, you're knowing exactly what that gallon of manure is that you're putting on the field right in that moment in time. With variable rate of application, there again, we're seeing the pumping systems that are coming out, again, with the liquid systems, whereby, depending upon what your soil map and yield maps are telling you, you can vary that rate anywhere from, say 1,000 gallons in this part of the field up to 8,000 gallons. So you're matching your nutrients to your soil characteristics and your previous yield conditions, again, for optimization of your nutrients. With respect to the manure sampling, the biggest forefront there is a technology called NearInfrared Technology. And what it is, as I said, real time. One of the companies that's on the forefront of this claims they can measure nutrients 14 times a second, every second that the equipment's running. So if you think about the sheer volume of data you're getting in terms of being able to make decisions and how that can truly move the ball forward. Right now, there are 3 companies working on this, or 3 institutions, I should say. John Deere in Europe, another company out of Europe called DTech, and right now the University of Washington, the only North American institution that's moving forward in this technology, developing the Near technology for the specific application, and somewhere down the road, they're also embracing, taking it beyond the liquid applications and looking at how this technology can be used on the solid side as well, in terms of taking both components, so both the liquid guys and the solid guys can take advantage of this technology. As I said, right now DTech and John Deere, in speaking to both companies, they have unfortunately no intention of bringing this technology to the North American shores. The University of Washington, they're in the trial stage right now, so they're looking for active partners within the industry, not only in the University of Washington, but across North America. They're looking for active partners where they can field trial this technology and, again, develop their own proprietary system to bring to the market. So just to give you an example of what the John Deere system looks like, as I said, presently only available in Europe. I used to work with John Deere when they had a plant in Welland, so I had some internal contacts with John Deere, and the consistent message I receive is that, like I said, no intention of bringing this to North American shore. They haven't gotten into specifics why, but I suspect they don't believe the market's ready for it. With the different structure of manure management in Europe, there's a little more focus about balancing your land base and your animal base and your overall manure capacities and bring the 3 together effectively. So it's a bit of a limiting factor for us here. But real-time and continuous measurements of dry matter, nitrogen, phosphorus, potassium, and ammonium. So with this particular system, there's like the other precision ag equipment, you have a monitor mounted in the cab of the tractor, and in real time you're seeing these numbers come up as you're doing your application rates. Utilize the full potential of the organics, maximize yield and product quality while cutting costs on mineral fertilizer. There again, it provides a roadmap where if you need 40 pounds of phosphorus in this part of the field, you have the information to actually do that, and same with the nitrogen. What's unique here is some of the next things where it's intuitively controlled. John Deere is very good at linking their systems together, and what you can do is with the prior application, you can define your target. So if you're going into a field where you want to apply based on your phosphorus level, as a primary condition, it allows you to set that up, and then as a secondary apply your nitrogen. The technology is evolving whereby if you're applying manure based on your phosphorus levels, we know typically you're going to be short on your nitrogen, and what the systems are evolving is to supplement the 2, you're having liquid urea injected in that liquid manure stream, so you're catching both nutrients at the optimum levels as you're doing your application across the fields. So there again, we're seeing application rates, from as little as 1,000 up into the teens, based on what your needs are in those particular spots in the field. So it really gives an opportunity to drive the economics home. And then finally, for convenience, you can predefine these application maps, again, on the Green Star 2630 system. John Deere system. With the non-John Deere systems, what they say is that it's not as automated. So there's a little more work involved to get this intuitive operation working for you as you're going down the field, but certainly the capabilities there, and this is what's on the horizon. So coming back to what I said before about the University of Washington, they're at the early stages of this in terms of they don't have obviously the breadth of what John Deere brings to the market in terms of technology and capabilities and across the board systems, but they are looking at starting that path down the road whereby we'll have a North American system available to everybody in the North American shores. DTech and John Deere just not coming for some reason. So, but it's a real opportunity to again get away from over applications in the instances where those can happen, and thereby reducing the risk associated with that. So with that, open up for questions. Great, this is fantastic. Oh, sorry.
I have nutrient management plan, how do I incorporate this kind of technology?
Good question, because yeah, you're looking at, or sorry, the question is, if I have a nutrient management plan strategy or plan, how do I incorporate this? And yeah, you're right, because you're looking at a fixed rate, right? So I'll say it would be a challenge, right? I mean, because certainly you're trying to manage if you have 300,000 gallons of manure, you need to account for all of it, right? And certainly with a variable rate, it does add a level of complexity. At the present time, unfortunately, I don't have an answer, right? I mean, I will say, hopefully we get to that point whereby, you know, the pluses and minuses, you know, you can come up with an average, but certainly it would be something to address on the plan, and how do you effectively do that and account for it, right? Because certainly, you know, in optimal years where you're applying your manure on land where you don't need as much, obviously you're going to be in a surplus, and then what do you do, right? I don't know if there'd be an opportunity to transfer out, but certainly you don't want to get behind the 8 ball where you're coming into fall with an overflow condition. Would be your worst case scenario. So, good question. Yes, sir.
Is the technology moving towards solids?
Yes. Yeah. Pardon me, sorry?
How far away?
The question is technology moving towards solids? The University of Washington right now, they're probably, you know, on the liquid side, they're somewhere within the next 2 years, 2 to 3 years of bringing something to market. And the initial conversation on solids was they foresee an overlap. So probably sometime in the next 2 or 3 years, they're going to start down that path to bring the solids online as well. The challenge with solids is you don't only have the variability in nutrients, but also the variability in density, right? So, yes, in the back.
I would hope when we do a nutrient management plan, we have to put a yield in. So I do a lot of precision ag. If we have yield data for several years that proves that this area of the field is 25% higher in yield, why can't we put a higher nutrient application on that rate using on that part of the field?
Very good question. Yeah, so the question is, based on precision ag, can we put a higher application of nutrients on based on basically a known historical information, right, of higher yield? And I would say, and probably the opposite is true too, right, where you have, areas of the field that are shining stars, if you will, where you can really get 250 bushels the acre. There are other areas, say a sandy knoll that's a little more stripped off, where, yeah, your yield's going to plummet, right? And so, yeah, it comes back to your question before about how do you get this information into a plan and still have a valid plan and account for all the nutrients. So, but yeah, I'm not sure. Yeah, unfortunately, I really don't have a good answer for your question. Sorry.
Well, as long as the MOE would accept that, we just provide documentation to the farmer's plan.
Right.
This is why we just paying $9,000 a year is what we're putting.
Exactly. Yeah, and that's something I'll say the ministries. I don't want to speak for the MOE or Matt here, but certainly that would have to be something that comes with the evolution of the technology, right? To keep up. Yeah.
But right now, the yield's the average of the yield of the field as well.
Correct.
And it gives you a total gallons that you're allowed to apply to that field per acre.
Yeah.
But when you variable apply the nutrients, your outcome should equal your average anyway. It's just some spots are getting higher, some spots are getting lower. Like right now, no one can tell me that everyone's getting 10,000 gallons per acre.
Right.
We all know the headlands are getting a little bit more.
Yeah, exactly. And same thing with that's a perfect example where your headlands, yeah, realistically you're getting a little more, but at the same time your headlands are probably seeing a little more compaction. So it's, it's a bit of a moving target, right? But yeah, law of average, you're right. I mean, if say historically you did 5,000 gallons an acre, whether you need it or not, law of averages says I would suspect that at the end of the day, that same field's going to get the same number of gallons. It's just going to be a little more accurately placed, right?
More really quick question.
Oh.
Any comment on the economics, the payback on this kind of system?
Unfortunately not, Matt. I mean, John Deere, for whatever reason, very tight-lipped. The guys internal to Deere I've talked to about this system, I mean, all I get is the standard answer, we're not coming to North America. I can't even get a price on a unit. They're obviously, selling well in the European market, but in terms of actual information, they have very little available on their webpage, and most of that is off the John Deere European-based sub-pages, if you will. But yeah, unfortunately, they're keeping it all tight-lipped. So, okay, thank you very much.